Hey guys, today we'll be solving the M1 paper from May 2024. This is the Edexcel M1. So let's just get into it. I already sat for this exam once. I'm going to be solving this again for you guys. So let's start.
Okay, so in the first question, it says the particles A and B have masses m and 3m respectively. The particles are connected by a light and extensible string. Initially, they rest on a smooth horizontal plane with the string slack. Particle A is then projected along the plane away from B with speed u. Okay, so if I just see what I have here, I've got a particle A and a particle B, and they're connected by a light string, okay? And now they have masses m and 3m. I always like to, sketch this out whenever there's a question like this. So we have the initial speed of u, particle A is projected, the initial speed u of A, so it's projected along the plane away from B. So the direction of A's velocity is to the left, or it's not necessarily to the left, it's just away from B, because B could have been this as well, right? And A could have been this. In that case, A would have been moving this way. So I'm just taking things like this so that I have A here, and therefore the velocity would be in this direction. So I have speed u, and I know that this has velocity 0 as it's at rest. Now I have, given that the common speed of the particles immediately after the string becomes taut. So when the string becomes taut, what happens is we can consider that as a collision. So when it gets taut, what happens is they start moving in the same direction. So this is the before, and this is going to be the after. So here the string was slack, and here the string is just taut. Okay, and okay, this is the after. And what they're asking us is that the common speed of the particles immediately after the string becomes taut is s. So they both have a speed of s now. So now to solve the first question, we have to find s in terms of u. So what I can do is make use of the conservation of linear momentum. So I'm going to write CLM. And what do I know about the initial momentum? So the initial momentum here is just mu. A is the only body moving. So mu is my initial momentum. And if I consider the direction, I can just take this direction as positive because everything is in this direction. So I don't even have to worry about putting in a negative sign before anything. So as this is the positive direction, this is going to be mu for the initial momentum, and the final momentum is going to be ms plus 3ms. This is the total final momentum. This is the final momentum of ball A, and this is the final momentum of ball B. Now we have to find s in terms of u. So I can already cancel out these m's, and I can write this down as u equal to 4s, and s is going to be u by 4. So we're done with the first part. Let's move on to the next. It says that find in terms of m and u the magnitude of the impulse exerted on A immediately after the string becomes taut. Magnitude of the impulse exerted on A. So we're talking about A only. So if we look at A here, the impulse. So when we actually so as particle A is projected away from B, and since there is a string between them, what's going to happen is as we project A, and when the string becomes taut, there's going to be an opposing force on A. Okay, so the force is going to be in this direction, and it's going to be provided by the tension, by the string. So the impulse is going to have a direction towards B. Okay, so this is my impulse, and I know that the initial velocity was u, and the final velocity, is s, right? And it's still in this direction. It has to be in this direction. Okay, so that's s. And what do I know about s? I know that s is u by 4. Okay, I'm just writing s in terms of u. Now I can construct an equation. I know that impulse is mv minus mu. V is the final velocity, u is the initial velocity. So the impulse here would be, since impulse is in the opposite direction and we're dealing with vector quantities, I'm going to take this direction as positive. So when I write down impulse, I'm just going to put a negative sign before it. Okay, the final velocity is mu by 4, and the initial velocity was u, and they're all in this direction towards the left. So I'm going to keep the signs as it is. So now I have mu. Okay, now if I just multiply both sides by minus, I get mu minus mu by 4. And what's 1 minus 1 over 4? That's 3 by 4 mu, and that is my magnitude of the impulse. Okay, that's my final answer. Let's move on to the next question. It says that two forces P and Q act on a particle. P has magnitude 10 Newton and acts due west. Okay, so let's consider this to be the particle. Okay, and we have a force P that acts due west. So west is to the left here, and it has a magnitude of 10 Newton. and Q has magnitude 8 Newton and acts on a bearing of 330. So a bearing of 330 essentially means 30 degree from the y-axis this way. Okay, because when it's a bearing, we consider the angle from the angle clockwise from the north line, right? So this is angle 330 degrees, the bearing. So this angle must be 30. Yep. Okay, and I know that this has a magnitude of 8 newtons. Now, they've given us that F is equal to P plus Q. F is equal to P plus Q. All right, so basically the vector is the resultant. F is the resultant of P and Q. So we have to find out the magnitude of F. So we're going to turn these magnitudes into their vector forms. How do we do that? So if I talk about P first, I can see that it's towards the left. And if I consider the horizontal as I and the vertical as J, then this P vector would be minus 10I. Okay, this would be minus 10I. And for Q, what I can write down is, so as this is 30 degrees, let me construct this triangle real quick. This is 8 newtons. This is 30 degrees, okay? So there are two components here. One is this. This is the vertical component, and this is the horizontal component. How do I find out these components? Well, I know that this angle is with this axis. So the vertical component is going to be, I'm going to denote the vertical component by QY, okay? So the vertical component is 8 cos 30. If you have trouble understanding, I can show you that why it's 8 cos 30. It's because let's consider this as QY and this as QX. So if I take the trigonometric ratios, then what do I have? I've got, if I take sine 30, I have opposite, which is QX, divided by the hypotenuse, which is 8. So QX would be 8 sine 30. And so cos 30 would be QY, which is the adjacent here. And keep in mind, this is the right angle. And that divided by the hypotenuse, we get QY equal to 8 cos 30. Okay, now, what I'll do is, I've got QX and QY, so now I actually have to find out the vector Q. How do I do that? Well, vector Q is essentially in the IJ form. In the IJ notation, how can I write this down? I could write this down as 8 cos 30I. And there's going to be a minus because we're going to the left. This 8 newtons horizontal component is towards the left, which is negative I. So we're going to put a negative in front, and we have a vertical component towards J. So it's going to be plus, and the vertical component is 8 cos 30J. 8 cos 30J. Okay. Let me see if I can find an exact form for these. 8 sine 30. So there is an exact form, so I could write this down as, if you put this in the calculator, you'll find that it's minus 4. Sorry, this is, wait a second. QY is 8 cos 30. Okay, yeah, this is going to be 8 sine 30, my bad. Right, so this is going to be minus 4I, and 8 cos 30 is 4 root 3. So we have found the vector forms of P and Q. And now basically F is the resultant of these. So if I just add these two vectors, minus 10I minus 4I plus 4 root 3J, I will find the resultant force in the vector form. So it's going to be minus 14I plus 4 root 3J. And they asked for the magnitude of F, and we all know how to calculate the magnitude. It's just root over 14 whole squared plus 4 root 3 whole squared. If I just put it in the calculator, I get 2 root 61 Newton. Ah, yes, I do remember finding this answer in my exam. So I think I was correct. Okay, this was quite tricky. I struggled with this, I think. But let's see if I still got this. So the question says that two particles P and Q have masses. Okay, fine. The particles are connected by light in an extensible string. A second light inextensible string has one end attached to Q. Now both strings are taut and vertical, as shown in figure 1. The particles are accelerating vertically downwards. So they're accelerating vertically downwards. Okay, good to know. Now given that the tension in the string connecting the two particles is 3 mg. So there is a tension here in this string between P and Q, and it's equal to 3 mg, the magnitude. So what's the tension going to be? So as P is falling, it's exerting a force on the string, right? So what the string will do is exert a force on P, and that's opposite and equal according to Newton's third law. So there's going to be a tension this way, and it's going to be equal to 3 mg. And similarly, as Q is also, it's moving downwards, and since there is a string here, wait a second, is this string connected somewhere? The particles are connected by letters. The second light has one attached to Q. Both strings are taut and vertical. The particles accelerating vertical. Given that the tension in the string connecting the two particles is 3 mg, find in terms of energy the tension in the upper string. So to find out this tension, okay, so I know that here the tensions are 3 mg, okay, and so yeah, this string is applying a tension on Q so that it moves downward. the tension is 3 mg. So I can make some equations here. First of all, let's consider P and Q as a single body. So in that case, in this whole body, there's going to be a force acting downwards, and that is the weight. And what is the weight? The combined weight of P and Q. The strings have no weight, as they already mentioned. This is light and inextensible. So the total weight is going to be 4 plus 2, that's 6m times g. So 6mg is the weight. So I'm going to do resultant downwards for P and Q. Resultant downwards, that would be 6mg minus, that's the total resisting force. So opposing force of this weight. So what's pulling this whole body up? It's the tension, right? And you might think why I'm not including this 3 mg. It's because I can actually show you there is a downward force of 3 mg. So let's actually include that, okay? And then, of course, there is a negative force as this is also trying to pull P up. So there's going to be a minus 3 mg force as well. And you can see that in the end, these two just cancel each other out. So that's why I don't have to actually include this tension right here. And then I could actually get this tension right here, which is T. I'm just going to write down minus T. Okay, this is the opposing force. And so this is the resultant force equal to ma, that formula. So I need the mass and acceleration. Do I know the acceleration? Okay, no, I don't. Okay, so it's going to be the mass I know is 6m, so 6ma. Okay, fine. So I've got an equation created here where I can make T the subject. So the tension is going to be 6mg minus 6ma. Okay, now we have to just consider one body. And I think it's best if we consider Q, because this tension is affecting Q, the particle Q. So it's better if I consider Q for once to make an equation that includes the tension T on the top string. So for Q, resolving downwards, we get, I know the tension pulling it downwards, which is 3 mg, okay? And what else? What else is pulling Q downwards? It's weight. So the weight is 2 mg minus the opposing force here is the tension. So that's minus T, and equal to the mass is 2ma, all right? So if we make T the subject again, T is going to be 3 mg, so it's 5 mg minus 2ma, all right? Now, I've got a system of equations here. This is equation 1, equation 2. If I solve these two, if I just equate these two, what do I get? I get 6 mg. So let me just write this down. Minus 1 is equal to 2. And so 6 mg minus 6 ma would be equal to 5 mg minus 2 ma. All right, so if we solve this, I can easily cancel out m on both sides. And then we're left with 6g minus 6a equal to 5g minus 2a. And I need to find out the acceleration to then put the value of the acceleration into any of the equations, 1 or 2, doesn't matter, to find out the tension. That's what they want, don't they? Yes, that's what they want. So if I just solve this, I find that g is equal to 4a. Therefore, acceleration is g by 4, 1/4 of g. Now, if I just put this in, let's say equation 2, I get 5 mg minus 2 mg by 4. What do I get? So it's like 5 mg minus mg by 2. And 5 minus a half is 4.5. 4.5 is 9 mg by 2. That is my answer. I think I got this in my exam as well. I hope I was right. I hope I'm right now as well. I don't have the mark scheme, but I'm just winging it. Okay. Okay, number 40. What's it saying? A non-uniform rod AB has length 6.5 meters and mass 1.2 kilograms. Okay, so the rod, and it's non-uniform, it has length 6.5 and mass 1.2. So we don't know that if the weight is acting in the center or not, because it's non-uniform. Now, the center of mass of the rod is 3 meters from A. Okay, now we do know. We do know where it is. It's somewhere here, okay? So let me just write that down. And the length is, so this is 3 meters, okay? And the weight is 1.2 times g. Now, the center of mass, okay, the rod rests on a horizontal step and overhangs the end of the step C by 1.5 meters. The rod is perpendicular. The rod is perpendicular to the edge of the step. A particle of mass 4 kilograms is placed on the rod at B. So we have a force of 4g on the rod here at B, and another particle whose mass is n kilograms is placed on the rod at D. So where is D? Where is D? Okay, so they mentioned that where AB is 0.5 meters. So 0.5 is roughly here, okay? So they placed m kilograms here. So the weight is going to be mg. Not the weight really, it's just the force exerted on the rod by the mass. Okay, now the rod remains in equilibrium and in a horizontal position. Find the smallest possible value of m. The smallest possible value of m. So I just have to consider what I call the principle of moments. So the principle of moments is basically the total anticlockwise moment is equal to the total clockwise moment. So if I use that fact, so if I consider C as the pivot, right? If I consider C the pivot, then my clockwise moments are going to be produced by this force and this force only. There are no other forces in the clockwise direction. So that's 4g times the distance from the pivot is 1.5. So this must be equal to the anticlockwise moment, the anticlockwise moment being 1.2g times the distance here is what's this distance going to be? It's just 6.5 minus 3 minus 1.5. 3, that is 2. So this is 2 meters. So 1.2 g times 2 plus, I have to find out the smallest possible value of m. So basically, if I had not put m here, what was going to happen? It was probably going to tilt and in the clockwise direction about c. And what's the smallest value of m that can prevent this tilt? That's what I have to find out. So let me just write down mg times the distance from the pivot is 5 here, so mg times 5, and I can easily find out m. If I notice there's g both sides, so I can just cancel them, and I end up with that's 6 minus 2.4 plus 5m. So m, if you just solve this, you get 6 minus 2.4, and then divided by 5, that is 0.72. Okay, that is my answer. And in the exam, I think I gave it in fraction, right? Yeah. That's why this 0.72 did not ring a bell. I was like, what? But then I saw 18 by 25, and that, that made me remember. I hope I got it right. The particle at B and the particle at D are now removed. Okay, and the new particle is placed on the rod at the point E, where EB is 0.9 meters. So what's happening is the particle at B, okay, so these particles are no more. Let me just erase these. And what they're saying is, I'm just going to erase these as well. Okay, wait, I can't erase the weight. That's always there, 1.2 Gs. Okay, now, a new particle is placed on the rod at the point E, where EB is 0.9 meters. So EB, 0.9. So it has to be somewhere here. And this is, do I know the mass of this? Okay, I just know the distance here, which is 0.9 meters, and the rod remains in equilibrium in a horizontal position, but it's on the point of tilting about C. So when it's at the point of tilting about C, that is also when the moment created by this force and the moment created by this weight right here is going to be the same. So I have to find out the magnitude of the force acting on the rod at C. So the magnitude of the force acting on the rod at C would be, so let's just consider the rod here. I know that the total downward force is basically 1.2 Gs plus the weight of this mass right here. Let's call that mg. Okay, so that's 1.2 G plus mg. So this is the total force downwards on the rod. So there must be some, since there is no vertical motion, there must be a opposing force that is vertically upwards, which is provided by this, what is it called? The step, I guess. So that normal reaction force is provided by this step, and this force is acting at the point C, as it's clearly mentioned that it's about to tilt. It's on the point of tilting about C, so there is no other contact between the rod and the step except at C. So this is where a reaction force is going to take place on the rod. Let's call that RC. All right, so I can derive an equation here that is RC must be equal to 1.2 G plus mg, where m is the mass of this new particle, which I actually have to find out. And how can I do that? With the principle of moments. And what do I know? I know the what is that called? Anticlockwise moment and the clockwise moment. They must be equal. So 1.2 Gs times this was 2 meters. I remember. Yes. So this must be equal to so this is mg, the weight or the force that is acting at the point E. That is provided by the particle. So mg times the distance between mg and C. So what is this? This is going to be 1.5 minus 0.9. I think that is 0.6. Okay, and now I can find out mg. Or let me just find out m. Well, if I found out mg, I could just put that straight in here and find out this reaction. But yeah, let's just find out m. The m is going to be, okay, the g's actually cancel out. What am I doing? 2 times 1.2 divided by 0.6, and that is 4. So we find out the mass. And therefore the reaction at C is going to be 1.2 G plus 4 G, and that is 6.2 Gs. I don't have to write this in decimals. In decimal places, I don't think so, because I'm not, yeah, so I think I can keep this in terms of G. Yeah, right. But G is an approximation, and they did not ask for, yeah, you know what, let me just find out. Yeah, let's just write this down as 60.8. Okay, so I'm just going to write this down in decimal places. 60.8 meters, fine. Well, that's the magnitude of the force acting on the rod at C. Okay, I hope that's right. So guys, yeah, so I just remembered, this is me after I solved the paper. So what happened was, after a few days of the exam, I found a mark scheme for this M1. Someone had solved it and, posted it online. So I just remembered that I actually have that. So I opened that to check. And right here, I put down 5. Right? So instead of this 5, it's actually supposed to be 4.5. Because, well, 6.5 minus 1. So what is this distance actually? So mg was right here, where this is 0.5. Right? So this distance is what I'm looking for. And this distance is going to be 6.5 minus 0.5 minus 1.5. Right? So it's supposed to be 4.5. And I'm sure in the exam, I did not fail to realize this. I really do hope. And the answer actually comes out to be 0.8 kgs. All right. But it really doesn't matter what I do at part B.
Part B is
Still. Wait a second. No shot. Did I also mess up in the distance here? Sorry for the inconvenience. But I think it just, helps you realize how important it is to stay cautious when solving these questions. Silly mistakes are inevitable, man. Oh man. So I think the mistake here is, so I did write down this 1.2g times 2, that is equal to mg times 0.6. I did find out that m is 4. But then what I did was, so this is actually 5.2 g's, not 6.2. What am I doing? Such a silly mistake, right? So be sure to, be aware of these silly mistakes. Just once you write down a line, go back and read the line and be quick because you don't want to lose your time. So this is the answer actually, and this is 50.96 newton, which is basically 60 newtons. So this is wrong. Okay, so I could have just edited this out of the video and do this again, but I just wanted to keep it to just so how crucial it is to stay aware of these silly mistakes, man. Section. Okay, this is the question that I missed out on, and then I realized at the end when I only had 10 minutes remaining that I had not done this. Oh my god. And then I had to speed run this question. Let's see. A parachute is used to deliver a box of supplies. The parachute is attached to the box. The parachute and box are dropped from rest. Okay. So let me just map this out right here. So I have a parachute and a box, and they're dropped from rest from a helicopter. So the helicopter is like right there. Let me just draw some stuff here. So this is the helicopter, and this just dropped the parachute and the box. So we have the parachute and the box, and it is dropped from rest, so I know the initial velocity, which is 0. Okay, and there's having a height of 520 meters, so the height is 520 meters. All right, then we have the parachute and box fall vertically and freely under gravity for 5 seconds. So they fall for 5 seconds, and let's say they arrive at some place here. Okay, let's say they moved this distance, and then the parachute opens. So right at this point, the parachute actually opens. Okay, this is where the parachute opens. Now, from the instant the parachute opens, it provides a resistance to motion of magnitude 3,200. So resistance to motion means that, so the motion is in this direction. So the resisting force would be in the opposite direction, which is upwards. So that's going to be 3,200 newtons. And the parachute and box continue to fall vertically downwards after the parachute opens. All right. And what does it say next? The parachute and box are modeled throughout the motion as a particle P of mass 250 kilograms. So that is also important. So we have a weight of 250 Gs acting on this whole thing, right? Of 250 Gs. The entire time, the weight is acting. Right, so the first question is pretty easy. It says the distance fallen by P in the first 5 seconds. How do I do that? Well, if I just list the things I know, I've got the initial velocity as 0, and I do know that the acceleration is 9.8. It's always 9.8, right? So I have to find out the distance. And what else do I have? I do have the time. The time is 5 seconds. So I can easily actually find out the distance. The distance is ut. I could use the formula ut plus half at squared, where u is 0, so I don't have to write down ut. So I'm just going to write down half times 9.8 times t squared, 5 squared. Okay, so this comes out to be 122.5. And yes, I do remember getting this answer. Okay, let's move on to number B. It says find the speed with which P lands on the ground. Okay. With which P lands on the ground. This took me a while to figure out in the exam. And in 10 minutes, bro, my heart was racing. Ugh. So, I need a couple of things. I already know after 5 seconds, it has fallen a distance of 122.5 meters. So what's the remaining distance? The remaining distance is 520 minus 122.5, which is 397.5 meters. Okay, so I'm going to consider this to be a separate motion. So a separate motion where there is a resistive force of 3,200 newton. Now I have to calculate everything again, because now the acceleration is not going to be 9.8 anymore because there is a resistive force. So what do? Let me find out the velocity at this point, and let me call this u, all right? I want to know the velocity here. I just need to know the initial velocity here to work things out. And how do I do that? Well, I have the initial velocity here, and I have the time, and I do know the acceleration, so I can easily find out this velocity. So this velocity is going to be the initial velocity, which is 0, plus at, which is 9.8 times 5. I basically used this formula, where v is basically u because I just denoted that as u, and this is going to be 49 meters per second. All right. So this is 49. Now what I have to do is I have to consider this. Let's take this as a particle P, as they mentioned, and I know the total downwards force, which is 250 Gs, and the total resistive force is 3,200 newtons, and I know that it's falling downwards, and I know that it's accelerating, because, yeah, it is accelerating. Yeah. Is it accelerating, though? Okay, it's not accelerating, but it's definitely falling downwards, because if you actually find this out, 250 times 9.8, you actually get 2450 newtons. And at first you may think that this force is greater, so this must move upwards, but actually no, because it already reached this velocity. So once the parachute opens, before the parachute opened, there's only 2450 newtons acting on the parachute on the box, but then a new force appeared, of 3,200. And what's gonna happen is, what's gonna happen? Well, now this particle P is going to, start decelerating. So let me just find the value of deceleration. How can I do that? I can just use the resultant force equal to ma, this formula. So in this formula, the resultant force would be 250 Gs. If I'm considering this to be the positive direction, then 250 Gs minus 3,200 will be equal to the mass, which is 250, times the acceleration. So the acceleration comes b minus 3, okay? So it is still falling downwards, but it's just decelerating, meaning that it's just decreasing its speed, but it's still falling downwards. Okay, this was a confusion I had in the exam, but later on I figured it out. So what I did was, I now know the initial velocity at this point, the point where the parachute opened, and that is 49, and I know the acceleration. I just have to find out the velocity, right? The speed at which with which P lands on the ground. So the velocity right here, so this is the ground. And I do know the distance, right? The distance was 397.5. So I can find this out with this formula, P squared equals to U squared plus 2AS. So the final velocity would be root over U squared. U is 49 squared plus 2 times minus 3 times S. S is 397.5, all right? 49 squared minus 2 times 3 times 397.5. So there's a decimal point here. Make sure you see that. And yeah, the answer comes out to be 4 meters per second. I vividly remember, I can recall that I got v equals to 4 in the exam. And I'm glad that I got it again. Let's move on to the next one. It says find the total time from the instant when P is dropped from the helicopter to the instant when P lands on the ground. So I already know that it took 5 seconds to come from the helicopter to this, to the place where the parachute opened. So I already have 1 time. So I just have to find out the time it took to come from this point to the ground. Well, I know the acceleration, I know the initial velocity and the final velocity, so I can easily find out the time. T2, okay? I'll let T1 be, what's that, 5, and T2 is going to be V minus U, 4 minus, the initial velocity is, what, 49, divided by the acceleration, which is minus 3. 4 minus 49 divided by, that's 15. So total time is going to be 15 plus 5, which is 20. আচ্ছা, so এরপর আমাদেরকে বলছে sketch a speed time graph for the motion of P from the instant when P is dropped from the helicopter to the instant when P lands on the ground. So the initial velocity here is 0, so I'll start the graph from here, okay? And then from 0 for 5 seconds, the box and the parachute accelerates to 49 meters per second. Okay, so it accelerates from here. Let me just draw a good straight line. Here to, let's say, 49. Okay, so I can see that, and I know that when it touches the ground, it reaches the speed of 4. So the graph is going to be a straight line from here to here, and the total time is 20, and this was 5. All right, and this acceleration has to be negative. Basically, acceleration is the gradient of a speed time graph. So we have to make sure the line that we draw here has a negative gradient, which equals to minus 3, of course. All right, on to the next question. That should be the answer, hopefully. Okay, next question says, oh, I love these questions. A box of mass M lies on a rough horizontal plane. So this is rough, and when it's rough, what I do is I just draw on the diagram this reaction force, and yeah, that's it. And then the box is pulled along the plane in a straight line at constant speed. So I know that the acceleration is 0, all right? And the rope is inclined at an angle theta to the plane. Okay, the coefficient of friction between the box and the plane is 1/3. So I know that if it moves in this direction, the force is, of course, going to be opposing. So the force is going to be mu r, the max friction. The max friction is mu r, where mu is 1/3, the coefficient of friction times r. Okay, and the weight is of course mg. All right. Then they asked for the tension in the rope. So I have to find out the value of T. And I've been given that tan theta is 3/4. All right. Now, I know that it's moving in constant speed. And when it's moving in constant speed, I can actually resolve this horizontally and say that d cos theta is equal to whatever force that is opposing this force, which is the friction, 1/3r. Right? Because the only horizontal force acting on the right-hand side is the horizontal component of the tension, and the only opposing force to this component of the tension is the friction, 1/3r. And I actually have to find out r now. What is going to be r? For that, we have to resolve in the vertical direction. So the vertical direction, I can see that on the box, in the vertical direction, I have a downward force, which is the weight, of course, which is mg, and what else? So there's going to be a normal reaction force that is exerted by the floor, which is r, and of course there is another force, which is the vertical component of this tension, which is T sine theta. Okay, so I can actually construct another equation here. I know that since there is no vertical motion, the vertical forces must be balanced. So r plus T sine theta must be equal to the weight. The weight is mg, no? Yeah, it is. Okay, so now I've got two equations. What I can do is, I've been given tan theta, the value of tan theta. So with that, I can actually construct a right angle triangle. So I know that this is opposite divided by adjacent. So this must be 3 and this must be 4. And we know in a 3-4 triangle, the hypotenuse is 5. This is a classic 3-4-5 triangle. So from this, I can actually find out sine theta and cos theta. So sine theta is going to be, considering this as theta, is going to be 3/5, as it's opposite divided by hypotenuse. I'm sure you all know this. 3/5, and cos theta is 4/5. All right. So now I can actually put these in these two equations. So in the first one, it's going to be 4/5t equal to 1/3r. Now what I'll do is I'll make r the subject here, so mg minus, and I'll just put the value of sine theta here, which is 3/5t, and I will be putting this value of r, this expression of r, into this r right here in 1/3r. Okay, so that is going to give me 1/3 times mg minus 3/5t, and if I just expand this, I get mg by 3, and so this 3 and 3 cuts out, and I have t by 5. So if I just take this to the other side, I get this, and 4/5 plus 1/5, that is going to be t, which is equal to mg by 3. I think that's what they wanted. Okay, yeah, that's the tension, and I found out the tension, so that is my final answer. And the next part says the rope is now removed and the box is placed at rest on the plane. The rope is now removed. The rope is removed, and the box is placed at rest on the plane. Okay, now the box is then projected horizontally along the plane with speed u. So let me just remove all these forces since they're not there anymore. I'm just going to rewrite them. Of course, there's the weight, and now we have the reaction force as well. And we know that this is a rough horizontal plane, so the friction is going to be 1/3 of the normal reaction. And then it says that the box is then projected horizontally along the plane with speed u. So I know the initial speed, which is u. And the box is again modeled as a particle, of course. And when the box has moved distance d along the plane, the speed of the box is half u. So let's say this is distance d. Okay, now if this is distance d, I know that at this point the speed is u, and at this point the speed is half of u. Okay, so we have these values. So what I can do is, since there is a friction acting, and we only projected this, so there is no other force acting horizontally. So ignore this completely. Wait, let me actually just can I lighten this out? Let me check. Wait a second, guys. Okay, just to make it clear, okay? Now, I have to find a new acceleration. And why do I have to find out the accelerating? So it's an acceleration, because, and how do I even know that it's accelerating? Rather, it's decelerating here, as we can see that the speed here is u, and here it's half of u, so it's of course decelerating. And why is it decelerating? It's because there's a friction acting, and there is no other force that is acting in this direction. The only force is this, which is the friction. It's the resistive force. It's moving in this direction, so the friction is of course going to be in the opposite direction. I hope that's clear. Okay, next, I can say that if I resolve, sorry, if I don't need to resolve this, I just have to. Okay, first of all, let me just find out the normal reaction force. The normal reaction force is just going to be equal to mg, because I know the only downward force acting on the box is its weight. So the amount of force required to keep it steady in the vertical direction is going to be the same as the weight. So that's going to be mg, and therefore the friction is going to be 1/3 of mg. And now I can actually find out acceleration with this, the sum of all the forces is equal to ma. The resultant force is equal to ma. So the resultant force is essentially minus 1/3r. I'm considering this direction to be positive. So the mass is m, and the acceleration is, okay, that's what I have to find. Okay, now in place of r, I think I can write down mg. And I can see that the m's cancel out, and I can see that the acceleration is minus g/3 meter per second squared. Okay, next up, I've just found out the acceleration. Then I'll be doing this. Acceleration is minus 1/3, and I know the initial velocity and the final velocity, and I know the distance. So I have to find d in terms of u. So I can actually construct an equation here. So I know that s is d, I know that the initial velocity is u, final velocity is u/2, and the acceleration is minus g/3. Now, looking at this, which formula can I use? I can clearly use this v squared is equal to u squared plus 2as. Okay, so v is u/2, so it's going to be u squared by 4. It's just u squared, and 2as, 2g/3. Of course, there's a minus times d, which is s. So now, what I'll do is I'll bring this 2g/3 to the other side. So I have 2g/3d equal to 1 minus 1/4 is going to be 3/4 u squared. Therefore, d is going to be, what is going to be 9/8 u squared. And that should be my d in terms of u and g. Wait, where is g? Oh, yeah, my bad. There's a g, I forgot to write this down. So it's 9u squared by 2g, and I actually remember getting this answer. Oh, such a relief. So that's my final answer. Let's move on to the next one. It says, where is it? Okay, well, this was a quite lengthy question. I hated this. But let's just see what it says. 2 speedboats, and they are each moving with constant velocity. The velocity of A is 40 kilometers per hour due east. All right, and the velocity of B is, so let me just write this down in vector form, right? So VA is due east. East is towards the right, which is the positive I vector, positive I direction in this case. So it's going to be 40I, all right? And the velocity of B is 20 kilometers per hour on a bearing of angle alpha, where tan alpha is 4/3. So basically what this means is, let's consider this the origin, and the direction of the velocity is on a bearing of angle alpha. So let's say this is angle alpha, and of course it's going to be from the northern direction, clockwise. So this is alpha, and they've mentioned that alpha is between 0 and 90, so we know that alpha has to be an acute angle. So the direction of the velocity cannot be this, right? Because that would mean that alpha is obtuse, but it's clearly mentioned that it's between 0 and 90, so it's an acute angle. Let me just erase that. Now, I've been given that tan alpha is 4/3. Now let me just make this the right angle. So now I've been given that tan alpha is 4/3. So what does that mean? If I have this, just like in the previous question, I think I used, not in the previous question, some questions before, I used the right angle triangle to find out sine alpha and cos alpha. So I know that tan is opposite by adjacent, so that's 4 and that's 3. Therefore, of course, it's the famous 3, 4, 5 right angle triangle, so it's just going to be 5. And if you are not aware of this, then you could just use the Pythagoras theorem to find this out. Now, I can find out sine alpha. Let's just do that. Sine alpha is going to be 4/5. That is opposite divided by hypotenuse, and cos alpha is 3/5 adjacent by hypotenuse. We've got these values. These are important values. Let me tell you why. It's going to help me in writing this velocity in the vector form, the velocity of B. So the velocity of B is VB equal to, so this is actually part A. They're asking for velocity of B in terms of I and J. So VB is actually going to be this component. So this is the direction. So the horizontal component is this, okay? This is a horizontal component. And what is this component going to be? This component is, as this is alpha, and this is opposite of alpha, we're going to take sine alpha, right? So it's 20 sine alpha I, 20 sine alpha I, plus the vertical component is here. So, and that is with the angle alpha. So we're going to take cos of that. So it's 20 cos alpha J. Okay. And now we know the values of sine and cos alphas. So that's 20 times 4/5 I plus 20 times 3/5 J. That gives me 16 I plus 12 J. All right. That is my velocity of B. Part A done. This part was actually quite tricky. I've never seen this in a past paper. This was rather new. It was interesting. Okay, so the next part says, at noon, the position vector of A is 20j kilometers. The position vector of B is 10I plus 5j kilometers at time t hours after noon. The position vector of A is R, where R is this. So this is another place where they tried to trick us. they gave the j vector first. So anybody, literally anyone, could actually just mistake this for 20i plus 40tj. Like, they really wanted us to fail this time. Yeah, so all right, where was I? I have to just find an expression for s in terms of t, I, and j. Okay, what does it say next? It says that at noon, the position vector of A. So at 12 p.m., noon is 12 p.m. if you didn't already know that. Okay, at this time, the position vector of A is 20j. Let's call that A naught. Okay, let's call that A naught. Wait, no. They've already mentioned that the position vector of A is R and B is S. So I can just consider the initial position vector as R naught, which is 20j. And the position vector of B is S naught, which is 10i plus 5j. All right, got it. And at time t hours after noon, the position vector of A is R kilometers, where R is 20j plus 40ti. At time t, the position vector of A is that, and the position vector of B is this. Final expression for S in terms of ing. So S is essentially just going to be S naught plus VT. VT is basically the extra displacement. So this was the initial position vector. And from this initial position vector, how much I have moved in what direction, that is basically VT. That is the extra displacement that's there, right? And that and adding these two will give me the, what's that called, the final position vector, which is S here. So S is, I know the S naught, 10i plus 5j. And I do know the velocity of B, which I just found out in part A, which is 16i plus 2j. So I'm multiplying t with this will give me 16ti plus 12tj. And now I'll just collect the i's and j terms. That will just make things simpler for, following questions. So I get 10 plus 16ti plus 5 plus 12tj. All right, now show that at time t hours after noon, the vector AB is this. T hours after noon. All right, so for that, let me actually find out the position vector. Okay, they've already given us a position vector of A in terms of T at time T hours, which is 20j plus 40ti. So R is 20j plus 40ti. All right, and S is, I just found this out, 10 plus. Okay, let me actually rewrite this with the I term first, because it's quite confusing. 40ti plus 20j, and S being 10 plus 16ti plus 5 plus 12tj. Now, what is the vector AB? The vector AB is essentially AO plus OB, right? And what is AO? So, okay, first of all, what is OA? OA is essentially R, right? That is my position vector relative to the origin. And OB is S. This is OB. So AO is basically the opposite direction. So I'm gonna have to take minus R, and OB is plus S. So minus R is minus 40ti minus 20j, and now I'm just gonna be adding the plus sign here. Okay. Now I'm going to collect the I terms again, because that's what I have to do here. We have to get to this expression. We have to show that it's AB is this. Well, if I just collect the I terms, I get what? 10 plus 16t minus 40t. 16t minus 40t would be 24. Okay. That is that. And well, this is going to be 12t minus 15j. Right. Make sure to add the brackets. And that is shown. Let's move on to number D. Okay, show that the boats will never collide. Okay. I remember it took me some time to figure this out. I don't know why. It should be easy. Let me see if I still got this. It says, so when the boats never collide. Okay, so if they never collide. Okay, let me first find out what happens if they collide. Or maybe I think I know what to do. And I hope I did this in the exam as well. So if I actually find out the modulus of AB, which is basically the distance between A and B, so the distance between A and B being modulus of AB, then if the distance is, if I actually put down D equals to 0, and for that, I'll see if I actually get a real value for time. Let's see if that works. So modulus of AB would be root 10 minus 24t whole squared. We're going to collect the I terms and square that, and add the square of the j component, 50 minus 15 whole squared. And now let's square root both, let's square both sides, and so we get d squared equal to, now we're going to just expand this to get 100 minus 2 times 20, 480. That's 480. 480t plus 24 times 34 is 576. All right, and here we get 144t squared minus 3 times 12 times 15 minus 360t plus 225. I hope that's right. Oh, I hate these. Yeah. It's all good. Now let me just rearrange this, and I'm going to put when d equals to 0. I'm just going to write a statement here that when d is 0, they collide as distance between them. Wait, distance between them is basically d, so I don't have to write that down. I'm just going to write this, that when d is 0, they collide. So let me just put this 0 here, and let's just put these in the calculator. So you have 576 plus 144. 720. 720t squared. I really hope I did this in the exam, man. Oh my god. Now I'm really stressed. Tomorrow's the result. I'm making this video the day before the results. I don't know what else to do right now. I'm so stressed. 840p. And we have 100 plus 225, and that's 325. I hope that's right. Yes, it is. Okay, now I'm just going to straight up put this into the calculator. And wait, actually, before doing that, what I'll do is I'm going to check if the discriminant here is less than 0 or not. So if it's less than 0, it means that there is no real root, right? So let's find out b squared minus 4ac. I think I did this in the exam. Oh, I really hope I did. Okay, so 840 squared minus 4 times 720 times 325. And it looks like, no, I don't think so. Is it going to be? Okay, no, I don't think it's supposed to happen. Let me just check. 840 squared minus 4 times 7 times 325. Oh, yes, it is. So we do get a negative value here. I thought that 840 squared would be bigger than this. Yeah, so it actually comes out to be minus 230, 400. I don't remember getting this number. I think what I did was somehow I think I equated the i's and j components and saw that I did not actually get a time that is common. Like basically what I did was, so I have these vectors, right? So when they collide, they're supposed to have equal components. So basically 40t must have been equal to 10 plus 16t. So then t would be what? 40 minus 16. 40 minus 16, that's 24. So 10 divided by 24. 10 divided by 24 would be 5 by 12. 5 by 12 hours, right? 5 by 12. But when I compare the j components of r and s, let's see what happens. 20 equals to 5 plus 12. I think this is what I did in the exam. That's why I couldn't remember what I was doing. Okay, 20 minus 5 divided by 12. And that is 5 by 4. So I think in the exam, now I remember I mentioned that these two times are not equal. So that must mean they do not collide, and that they just happen to be at a certain position vector, but at different times. So they actually do not collide. They're never at the same position vector together. Right, that's what I did. But I think this should also be in the mark scheme, right? So I should just write this is less than 0. So no real solution for time. Therefore, they do not collide. I think this is also acceptable. I hope so. Oh my god. I just hope this is acceptable in the exam. Okay, now I'm even more stressed. All right. Let's just do this. Find the distance between the boats when the bearing of B from A is 225. The distance between the boats when the bearing of B from A is 225. Distance between the boats when the bearing of B from A is 225. So we have the vector AB, right? So the vector AB is this. So I can actually... okay, so they're saying when the bearing of B from A, so let's say A is at a certain point here. Now what's going to happen is we're going to have to move clockwise from this north direction, 225 degrees, and then that's where my B is going to be. So 225 would be, well, I already know this is 180 from here to here, and an extra 225, an extra 45. So it's like here, right? But this is 45, and this is 45 as well. 45 is basically because this whole thing is 90, and sorry, wait, this is 180, and I have to go to 225. So 225 minus 180 will actually be 225. Sorry, 45. So this is 45, and that's 45. All right, that's clear, I hope. Now, they're saying that B is somewhere here, but in this line, right? I'm just considering that B is here. Now, I do have the vector AB. And I think in the exam, what I did was I found out vector BA. So BA is basically just going to be the negative of AB. So the negative would be 24t minus 10I. Okay, so I found out BA to, get this vector, because if this is 45 and this is a right angle, then this must also be 45 degrees. And basically this horizontal component is now 24t minus 10, because this is the I component. This is the BA vector. So this must be the horizontal component, which is 24t minus 10. And the J component will be 15 minus 12t. So this will be the vertical part here. Right, and we have the angle, and we also got these two sides, and we can clearly use tan 45 here. Tan 45 is equal to opposite, which is 15 minus 2t, divided by the adjacent 24t minus 10. Now you could have also used this angle and you would end up with the same equation because tan 45 is actually 1. So now you multiply both sides by 24t minus 10 and you end up with this equation. And now if you solve this, you get this, so t is 25 by 26. And now they asked for the distance between the boats when this is at this bearing. So the distance we already found out. So we just found out the time. We can, we've already found out that expression for the distance, right? Distance between the boats. I think, yeah, so I think in the exam, as I already did this, what I had to do next was actually go through this step again. Not again, in the exam I did not write this. So now I would have to actually do this again, but I don't know if they'll accept it because, I don't know really, because this should be part of D, finding out the position vector AB. But, oh no, we already have position vector AB. Oh, right, this was part C, my bad. Okay, so now we actually have to find the distance between the boats when the bearing is this. So when is the bearing of B from A 225? It's when the time is 25 by 26 hours, right? So if I put this value of time in the vector AB, I can just find out the displacement between A and B. And with that displacement, if I calculate its magnitude, I will end up with the distance. And since I already did this in part D, I'm just going to take this distance. So D is root, and then 10 minus 24 times, I'm going to put the value of T, okay, 26, and then whole squared, plus 12 times 25 by 26, minus 15 whole squared. And now I'm going to put this straight into the calculator and see what my answer is. 10 minus 6. And it comes out to be 13.5 kilometers. Okay, that is the distance. I think, oh man, this 13.5, I'm not able to recall if that's what I got in the exam. I'm sorry for being really emotional, guys, in this video, solving this paper for you, but it's just the reality, man. Tomorrow is my results. Okay, let's go to question 8. Make sure we're done with everything here. Yes. Question 8 says, one end of a light inextensible string is attached to a particle of a mass. Yeah, I like these questions. Okay, let's start. So whenever I see these questions, what I do first is just label its weight and everything, right? So this has a weight of 2 mg, and this has a weight of 3 mg. There's a tension acting here, and there's a tension acting upwards here. We all know that. And the other end of the string is attached to a particle B of mass 3 m, blah, 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 held on a rough plane. So since it's a rough plane, what I'll do is I'll mention the reaction force, because that will help me find out the friction here, right? There is a friction which is equal to mu r. And do I know the coefficient of friction? Do I have to? Yeah, we do have the coefficient of friction between A and the plane, which is 11 by 36. So the friction is going to be 11 by 36 r. Okay, so we have labeled everything, and we've been given the tan of s 5 by 12. I'm just going to prepare myself the right angle triangle. I know that this is 5, this is 12, and this must be 13. This is another right angle triangle. You should notice that if two sides are 5, 12, the hypotenuse is always 13. Then we have the string hazard smooth pulley, which is at the top of the plane. Particle B hangs vertically below P with string dot at height h above the ground. So this height h is given. And the part of the string between A and B, that is, okay, we don't have to read that. That is just whatever. The coefficient of friction between A and the plane is, okay, we already have taken note of that. And the particle A is released from rest and begins to move up the plane. So I know the initial velocity is 0, and they start moving upwards, and B starts moving downwards. Okay. And I have to show that the frictional force acting on A as it moves up the plane is this. So basically, to find out the frictional force, I just need the reaction force. And what is going to be the reaction force? So I know that if I consider the particle here, I know that the downward force is 2 mg, and there's a reaction force here. And what's happening is I can see that there is no movement of this ball perpendicular to the plane. So there's no movement in this direction. So what I can say is that this reaction must be equal to this component of the weight. And I know that this angle is alpha due to geometry. If this is alpha, this is also alpha. So R is, if I just resolve in this direction, I get that R, the reaction force, is equal to 2 mg cos alpha. Cos because this alpha is actually with this line, so it's going to be 2 mg cos alpha. And we do know what cos alpha is. From this right angle triangle, it's going to be adjacent by hypotenuse, which is 12 by 13. So 12 by 13 is, right, 12 by 13 multiplied by this, that's going to give me 24 mg by 13, and that is my reaction force. And now I can find out the frictional force, which is 11 by 36 times this. Quite a weird one if you ask me. Okay, I'm just gonna put this in the calculator. 11 by 24 divided by 13 times 36. And yeah, we do get 22 by 39 mg. Of course, I got this right in the exam. Otherwise, I wouldn't be able to proceed to the next question. So I have to write down an equation of motion for B. So just considering B, this is B. I know that there's weight, okay, and there's a tension, a certain tension pulling it up. We don't know what that is yet. But I think they're just asking us to write everything in terms of T, I hope, right? Have they mentioned, okay, no, yeah, it is accelerating. I thought they would be moving it at constant velocity. I don't think that's possible here. Okay, so these are the forces acting on B, and I know that it's moving downwards, and it's accelerating downwards. So what I can say is, if I resolve it downwards, and if I take, the resultant force equal to ma, if I consider this equation, I can say that 3mg minus t is equal to ma. I think that should just be the answer. That is 2 marks right there. This is the answer for part B. Now part C says, show that the acceleration of A immediately after its release is 1/3 of g, the acceleration. All right, so now we have to do some work with A as well. For particle A, I can see that it's moving upwards. So we're going to resolve it in this direction. And in this direction, there is a force, which is the tension, right? Provided by the string. So tension minus the opposing force is force of friction, which is 22 mg by 39. And do not forget, and I've seen many people forget, and I am one of them. They forget to take into account this component of the weight. The weight has a component that is parallel to the slope that's acting downwards. So we have to take that into account, which is basically 2 mg sine alpha. 2 mg sine alpha. And what do we know about sine alpha? Sine alpha is 5 by 13. So 2 mg times 5 by 13. That is equal to ma. And what is the mass? The mass is 2m. Wait a second. Oh my god. I hope I did not make this mistake in the exam. I forgot to write down the mass of B. It's 3m. 3ma. Oh my god. Okay. Now, the mass of A, that's what I need, that's 2ma. I have to find out the accelerations. If I just solve this equation, if I just make the t the subject and then equate these two equations, I can solve simultaneously to find out the value of accelerations. I'm going to make t the subject here first. It's going to be 3mg minus 3ma, all right? And if I make t subject here, I get 2ma plus, so I'm just going to add up 22 by 39 and 2 times 5 by 13. That is 4 by 3 mg. 4 mg by 3. Now, if I equate these two, let me just write this down here, man. 3 mg minus 3 ma. I can see that the m's cancel. And if I just multiply by 3, I'm basically multiplying both sides by 3 to cancel out this 3 in the denominator. Then I get 6a plus 4g equal to 9g minus equivalent 9a. Right, so now I have to find out acceleration. So 9 plus 16 is 15a equal to 9 minus 4. That's 5g. And therefore, a is 1/3 of g, and that is shown. Yes, we got it. Okay, next part says in subsequent motion, A comes to rest before it reaches the pulley. Find in terms of it the total distance traveled by A from when it was released from rest to when it first comes to resting. So wait, what? The total distance traveled by A from when it was released. Okay, so I already know the first part is going to be, let me call it D1. That is going to be H, because if you notice, they're moving together. So as B touches the ground, it moves a distance of H. And similarly, A also moves a distance of H. So I'm going to name that D1, and that is H. Okay, and then what happens? As B touches the ground, the string goes slack, and there is no more tension throughout the string, and therefore there is no force pulling A up. So since A already had a velocity when it traveled h meters, that velocity has to reduce to 0 as there is friction acting. So when it reaches, and it clearly mentions here that A comes to rest before it reaches the pulley. So as it reaches the pulley, it comes to rest because it's decelerating. And why is it decelerating? It's because there is an opposing force, which is the friction right here. So that friction causes it to come to rest. And then what does it say? Total distance traveled by A from when it was released from rest to when it first comes to rest again. So first comes to rest again at this point, just before reaching the pulley. So I have to find out this total distance. Let's call that S. So I have to find out D2, and I already know D1, which is equal to H. So that extra distance, how do I actually find out that extra distance? For that, I need to find out the initial velocity at this point when it has already moved a distance of H. How can I do that? Well, I have the acceleration and everything. So if I just find out what velocity, B had when it touched the ground, then I would know what the velocity A has when it reached, this point right here when it traveled h meters. So that velocity would have, okay, if you have a question why that velocity is equal, well, this is a connected particle situation right here. So they both have the same speed at all times until the string goes slack. So let's find out the velocity of b at this point. How can I do that? I'm going to find that in terms of h, of course. So I know that the distance is h. And so okay, let's not call this s actually, let's call that d. Okay, so if s is h and the initial velocity was 0, they started from rest, and I know the acceleration of both the particles was 1 by 3g, and I just need the final velocity, so I can actually use v squared equals to u squared plus 2as. So if I just do root and then u squared, that's 0, so 2 times 1 by 3g s, not s, sorry, that's h. So I have 2 by 2gh by 3. All right. Now, what can I do now? Right, so now I actually have the velocity at this point. Let's call that v. And I know that just before reaching the pulley, it reaches a speed of 0. It comes to rest. And how does it come to rest? It decelerates. And do we know the value of this deceleration? No, we don't. And you may ask, why is it not this one? Well, now it's a totally different situation. There is no tension, right? The only force acting is the friction. So since the forces have changed, the acceleration will also change as F is equal to ma due to Newton's second law, right? So we have to calculate this new acceleration, which how are we going to do that? Well, let's just use resultant force equal to ma, and we know I'm going to take this direction as positive, moving up the plane. That's going to be positive. All right, so the resultant force there is going to be the weight and the friction. So the friction is, we just calculated that, minus 22 mg by 39, and the weight is that is basically the component parallel to the slope, which is of course 2 mg times is going to be sine alpha. Sine alpha is 5 by 13. So 2 mg times 5 by 13 equal to the mass times acceleration. The mass is 2m, and the acceleration is what I have to find out. So I can clearly cancel out the m's on both sides and maybe divide by 2. Divide both sides by 2, right? So that would give me 11g by 39 and 5 by 13g equal to a. So acceleration comes out to be by 39 minus 5 by 13. Acceleration is minus 2/3 of g. Okay, and now what I can do is now I know that at this point right here, this is where the string goes slack, right? So here the velocity was, where is it? Root 2gh by 3, right? Root 2gh by 3. And here the velocity, like just before reaching the pulley, it comes to rest, which means the velocity is 0. So I know that the initial is root 2gh by 3 and the final is 0. And I've also got the acceleration. So I can easily find out that extra distance that a travels. So s is going to be v squared minus u squared divided by 2a, and that is essentially just minus 2gh by 3, because this whole squared is going to be just 2gh by 3, and that divided by 2a, and this actually gives me minus 2gh divided by, oh, I've got to put in the acceleration as well, right? So the acceleration is, of course, minus 2g by 3. All right, so the minuses cancel out, and well, what else? Well, I just have these two, so they cancel out as well, and I'm left with gh by 3 and 2g by 3. So what happens is this 3 goes up top, so we have 3gh, and this 3 comes down, and that gives me 6g. So these two cancel out, and we get h by 2. So this is the second distance. Let me call this d2, and d1, as I've already mentioned, is h. So total distance d is going to be equal to h plus h by 2, which is 3 by 2h. And that is it. Do we have any other questions? No, we do not. So that is the end of this paper, and I'll see you in the next video.